Like any new SolidCam milling operation, we need to start a new milling operation, of course. And then, of course, we need to define the stock and then the geometry of it, or the coordinate system part. Since I forgot to define the stock block, I'll do it now. And then just add a new probe operation. You just add add new probe operation. And of course, like any milling operation or probe operation, of course we need to define which part we are doing. Since we want to find the height of this part here, we'll use single point Z, and we'll define the geometry to be here. And the tool we'll be using is the standard one, which is this. And for the tech, the zero level is to define what the probe will touch, until the probe will touch. So it will be until this point here. And when you're done, you just save and exit. You can see the probe going there, which hit the geometry and then define the height. So second of all, we want to find the height of this geometry. So we'll start a new probe operation. It's the same technology with new geometry, which will be here. And then use the same standard tool. And of course, you need to define the Z level. Since this both geometry are identical, I will just only do the first part. And then of course, the height of the step holes, and then this geometry and the inside geometry of this. We want to find the height of these step holes and the geometry of the contouring here and here. Of course, we need to just find a new geometry, define the new geometry, and then because the small height here, we will use a different tool, which the probe will be smaller than the standard tool. The solid diameter should be smaller than the diameter of the probe itself, so that's why it's smaller. And then we'll use this second tool. And then of course we need to find the height. And then we need to find the other two contouring height. And finally, the height of the step hole. For the step hole, we will use the standard tool. Now we want to find the diameter of the holes. To do that, of course, we need to start a new operation, but a different technology, which will be hole. This will find the diameter of the hole itself. So we'll start a new geometry, which will be this. Sorry, not that, but this. Since we want the circular diameter of the hole. Then the tool we'll be using is the standard tool. Of course, we just want the diameter of it, so we just want the probe to touch until here. So we'll define the height to be here. And you can see the simulation here. It shows how the probe will touch the diameter of it and then calculate the diameter of it. Secondly, we will find the diameter of the step hole and the hole here. Since the holes are quite small, we'll use the second tool. And of course we need to find the geometry first. And you can also define how many touch points should be to make it more accurate. Since this is quite a small hole, I'll probably just use 3, it's fine. And it shows us how big the hole is. I made a mistake, the height should be until here. And of course it's identical, we don't need to do it again. And then of course we want to find the diameter of the hole itself, the smaller hole. It's the same thing. because of the nature of the small hole, we'll use the second tool. And then of course the sea level would be until here. Since these 4 holes are identical, I want to these 2 holes. And then of course we want to find the radius or the diameter of this corners here. To do that, we'll use an external arc for this and internal arc for this. And to define the geometry, we'll use curve and closed corners. And we'll use the select tool. And then for the internal corners, we use internal arc. We define the geometry of it. And then we'll use the same select tool. And then we can find this arc and this arc here. With the same technology. And using the same tool. And finally we will find the arc here. Using the select tool, of course, and defining the geometry. So this is all the operation the probe and the CMM machine, the CMM mill will do with the probe itself to define the part and measure the geometry of the part. For the G code itself, we just need to do G code all to generate G code. And this is the G code. Thank you.